Okay, we've learned a lot, right, about hypothesis tests and how to pull all this off. So let's put it into play. So here's our first example. Humira is a medication used to treat rheumatoid arthritis. In clinical trials, Humira, 705 subjects diagnosed with RA, rheumatoid arthritis, were administered 40 milligrams of Humira every other week. I may be saying that wrong, I'm not sure. Of the 705 subjects, 66 reported nausea as a side effect. It is known that the proportion, keyword, of RA subjects in similar studies received a placebo who report nausea as a side effect is 0.08. Does the sample evidence represent significant evidence that a higher proportion of subjects receiving Humira experienced nausea as a side effect than those with the placebo? Here is my level of significance. All right. Okay, so we're looking at this, and now granted, I know that this is the section that we're dealing with, but you're not going to know that necessarily like for your test or just in general. So I know that I'm going to be using a proportion because it says it. I also know that I'm going to be looking at a proportion because it's giving this to me as this nice decimal with these proportions. Also, look at this word higher. What do we know about higher? What symbol are we going to be using? Yeah, we're going to be using that greater than symbol. So step one is setting up our hypothesis. All right, so here we are, H naught and H1. So P, because this is a proportion, it's always P equals, and then I'm at 0.08 because that is the current data that I have. My question is wanting to know, is this a higher proportion? Am I thinking something's going to be higher than 0.08? Right? My new thing is going to be bigger than what my current information is telling me. So I know that this is going to be a right-tailed test that we're looking at. And that's just good info. We don't really have to deal with it. Okay, so then remember, let me swing back here just real quick. Then we have this, so that was step one. Now we have this little set of data that we're going through right here. The sample is random, nailed it. We need to look at this criteria, make sure it's greater than or equal to 10, and we have to make sure that our sample is less than 5% of our population. So if we're looking, let me get my pen back here. For our criteria, so here's step one. Let's look here at step two. Number one, this first part is a randomized experiment. So we're good there. That's my first bullet. Here's my second bullet here of NP, 1 minus P has to be greater than or equal to 10. So plug that in. My number that we have is 705 because we were told that's how many subjects we're looking at. P here is that 0.08. We know that right up here, right? That's my P, and that's what the data we're given. 1 minus 0.08 has to be greater than or equal to 10. Okay, plug that in your calculator. What are you getting? I'm getting 51.888. Is that greater than or equal to 10? Boom, nailed it. Okay, the third thing is that my sample is less than 5% of my population. Well, let's talk about this for a second. I'm looking at 705 subjects. I lost it for a second. 705 subjects. Is that going to be less than 5%? Let's just look at it, the United States. It doesn't say specifically where, it just says subjects. Let's say we were only sticking with the US. Yeah, we're good, right? Because if we have less than 5% in the United States alone, the sample is less than 5% in the US alone, right? Regardless of where else we're pulling this from. So we're okay there. All right. Then step 3 is where we go to stat crunch. All right. So here's step 3. And I'm going to write our steps down in stat crunch. So we're going to hit stat, and I'm going to show you, but I'm afraid I'm going to forget to write it down. So that's why I'm writing it down now. Now we're talking about a proportion, right? Have we looked at proportions before? Yeah, we did in chapter 9, right? So we're going to go to the same place. Proportion stats. And then we're just still working in terms of one sample. Now this one is going to be with summary because I don't have like data, and we won't have a big pile of data that goes through this because we've already got the info that goes with it. All right. Okay. So let's come over here to StatCrunch. Let me move this out of the way. We're going to go stat. This is P because that's my height. Let me scoot this over again. This is my P for proportion stats. So we're doing proportion stats, one sample with summary. Now I'm going to scoot this up. Our number of successes is 66 out of 705. Let me show you that. From our problem, 66 reported nausea out of the 705. So your problem gives you that info right where it is. Okay. And then we are doing a hypothesis test. I'm going to keep this over. Well, it's going to go away anyway. We are doing a hypothesis test. Notice it automatically has P equal because it is, right? We know that to be the case. Whatever is happening here is going to also happen here. We just have to put the alternative. They put an A instead of a 1 there, which is fine. It's whatever. So we are looking at 0.08 and we want to change it to greater than. So we're going to change this to greater than, and then this is changing to 0.08. And see how it automatically changes it there. This is where the exact same place we did the confidence interval, except we're doing the hypothesis test this time. Then we click compute. I'm going to scoot this over so I can write on it at the same time. And it gives you the p-value, right? Here is 66 out of 705. I know it's a proportion that we're looking at. I don't care about these things. I do want the p-value. And we're going to go with, I don't know, I mean, there's only 4. Let's just do 4 decimal places. 0.0913. That's my p-value. So we're going to write that in here. So p-value is equal to 0.0913. All right. So here's the big criteria. So step 4 that we're looking at is we're making the comparison. If the p-value is less than alpha, we reject. So let's make the comparison. 0.0913, is that less than 0.05? No, right? 9 is bigger than 5. So this actually goes in that direction. So 0.0913 is bigger than 0.05. So my criteria tells me, remember, the p-value has to be small in order to reject. It's a bigger, not by much, but it's still bigger, and that's the whole point. Do we reject? No, because this is bigger, we do not reject. All right, because my p-value is bigger. So the whole deal is we figure out that p-value. Once StatCrunch gives us that p-value, then that's how we determine if we reject. So we are not going to reject. What does that actually tell us? When we state our conclusion, is there sufficient evidence to change our mind? No, right? We are not going to reject. There is not sufficient evidence to conclude the proportion of subjects taking Humira, to conclude the proportion of subjects taking Humira who experience nausea. I almost forgot that part. Who experience nausea is greater than 0.08. Greater than 0. There's our 5 steps. And check this out. Does the sample evidence represent significant evidence that a higher proportion of subjects receiving Humira experience nausea? Proportion of subjects who experience nausea, greater, right? Higher proportion, greater. You need to put those words in there. Not sufficient evidence. We do not reject. That means what they came up with originally still holds true. Still holds true. This new set that I'm looking at of 705 subjects is not enough to change our mind. It is known that the proportion in similar studies receiving a placebo who report nausea as a side effect. I already know that. It is known. So of these reporting nausea, it's not enough in order to change our mind. So we do not reject. There's not sufficient evidence. We keep the original information. You see how that is? Do not reject. I know there's a lot of nots and negatives in here and reject. So it seems like a double negative, but that's what it's saying. All right.